Hello guys, we are back. We're going to do the video just now, the live. There is a question that we're going to solve about vectors in 2 dimensions. Vectors in 2 dimensions, the Cartesian plane for the gray 11. And it's very important. It's a very important topic because it helps you for the upcoming Newton's law. And this is related to grade 11 as well as grade 12. Okay, so let's solve this question. It's a very important question. Let's see some common mistakes and how can we avoid those mistakes. And this question, I fixed it from a previous question paper. So let's have a quick look at the question. All right, the question, say three forces act on a point as shown in the diagram. And then there are the three forces, 500, 600 Newton, and 450 Newton. And the angle, I don't have to read because you can actually see it in the picture. All right. Now, before we even start working, you have such Cartesian plane where you have different forces, and some of the forces are not on the axis. Then you have to determine the components of those specific forces, or at least draw it to get an idea of the components. Let's have something just to record something about triangles before we even go to that question. Let's remember the following. If you have a triangle right angle, which I'm going to draw a hypothetical one, this is not to do with that question. This is mathematics. All right, and let's say the angle we are going to work with is this one. If you go to the question, if we go back to the question, we can see the angles, they are on different positions. So this one is it's very important. It's very important to know where the angle is going to be. So let's go back here and let's have a look. There are important things. Let's say this one is theta, and what we need to know. The side of the triangle, which is opposite to that angle, we call it opposite side. All right, the side of the triangle that is actually touching that angle, which is in this case, this one is the adjacent side. Now, this one is very important. Opposite to the angle, adjacent to the angle. And this long one, which is opposite to the 90 degree, is what we call hypotenuse. I am using symbols, but this one means opposite side. This one means adjacent side. This one is the hypotenuse. All right? So now, if we look here at this, mathematically speaking, we know that sine theta is equal to opposite side divided by hypotenuse. Let me just fix that one. That one is not an H. I think I was going to write another A there. This one is going to be hypotenuse, an H. All right, if we're speaking about the cos of the theta, cos of the angle, that is equal to adjacent side divided by hypotenuse. Now, what is the common mistake? Learners learn that always in x is going to be cos and always in y is going to be sine. That is not like that. It's not necessarily going to be like that all the time. It can change because it depends where is the angle. So you have, or you need to have that in mind. Apart from this one, and very useful for the direction, you use tan of theta is opposite side divided by adjacent side. Okay, now this one is related to the question because we need to identify which one is opposite and which one is adjacent. So that one is extremely important. Let's go back to the question, which is here. This one is the drawing. And let's do the components. Let's show the components so you know which one is opposite and which one is adjacent. Why is important to identify? Because a common mistake in the exams is to always say that in x is going to be cos and always in the y is going to be sine. And it's not like that, guys. It's not like that. It depends on the angle. Let's go to F1, which is this one. You can see the angle this time they use is right at this point. So if we break this force into components and we come down here, for example, with dotted line, here is going to be the x component. This one here is F1 in x, or the horizontal component of the first force, or force 1. If you take it to the y-axis in this direction here, you get that this one will be F1 in y. Now, from the drawing, you can see that F1 in y is next to the angle. So in this question, F1 in y is actually cos because it's the adjacent side. All right? So we can see from the picture. Instead here, the F1 in x is opposite. You go, is this one here, is opposite, and therefore it's going to be sine of theta. So from here, we can actually write those forces. Let's write it. Let me get another pen. This one is a little bit not writing so nice. Here is the one. So let's write here, F1 in x is the opposite side in this question. So it's going to be F1 multiplied by sine of theta, which in this case is 30 degrees. Okay? I hope that is clear. I hope that is clear. F1 in y is the adjacent side in this question, and it's going to be F1 multiplied by cos of theta. This is very important for Newton's law because you will have questions where the forces have certain angles with the horizontal. So we need to know in what direction they are, where is the angle in order for us to be able to calculate the components. So this one is for the first force. And any question, regardless of what they ask, this is the first step. You have to get that force that is not on any axis into the axis. Okay? Now, for F2 is the same. We have to take F2 and break it into components. So let's do that. Take projected here to the x, and you will have here F2 in x, which is this point here, right? Let's not get confused. F2 in x, this case is, or this time, is adjacent to the angle and is therefore going to be the cos of theta. So here is going to be equal to F2, whatever value is going to be, multiplied by cos of theta. Note that F1 in x, we use sine, but F2 in x, we use cos because of the angle that we're working with. Okay? In this case, in F1, the x component is going to be opposite to the angle. That is why we use sine. But if we go to the F2, the x component is now going to be the adjacent side to the angle. That is why we use cos. All right? But if we do the component for the y-axis here, we project it to the y-axis and we do it here. Remember, this side here is the same as we draw it on that side. It's opposite from a right angle. This one is going to be the opposite side to the angle and is therefore going to be sine. So this one is F2 in y, which is equal to F2 sine theta, which is 50 degrees. I'm going to just write sine theta And let me move that one a little bit up. There we go. So that is how we calculate or how we determine the component of those two forces differently. Because in one case, the horizontal component is going to be the opposite here, and in the other case, the horizontal component is the adjacent. So you have to be able to find out which one is the adjacent and which one is the opposite. Now, what about F3? F3 here is right on the x-axis, so it doesn't have any component on the y-axis. It only have the x component, which is the same vector. All right, this one is just more drawing that indicate us and show us how to do the calculation. So I recommend you highly to do this roughly drawing, in which you know which one is the opposite side, which one is the adjacent side, so you know the trick from mathematics, which is here. It's very simple. If you think you're going to get confused, just draw a triangle and identify which one is the opposite and which one is the adjacent. Mistake is to learn that in X is always cos and in Y is always sine. That is incorrect because it's not like that. It depends the angle that you are working with. However, mathematically speaking, you can always calculate this angle. But why will I do that? Why will I now do more calculations if the angle is easy to identify which one is the opposite side and the adjacent side? So this one is the analysis before we start working. And common mistakes, we already spoke about that one. Let's go quickly and look at the question. Let's have a look to the question real fast and start answering now the question. We identify, we know what not to do, and so on. The first one says resolve each force into the x and the y component. When they say resolve, this means they want to actually calculate it. So we are going to calculate. I'm going to use the other little board, which I'm going to erase here. I'm going to erase here. Let's see if I can print this. So I can calculate. Now you have to do the calculation. We first know the formula. Now we calculate. We're going to do it right here. We're going to make use of both little boards. So let's go for F1. And I'm going to write for F1. So all calculations related to F1. First, F1 in X, remember, do not memorize that it's always going to be multiplied by cos because it is not the case. Sometimes look always at the angle and identify the opposite or adjacent. You can summarize it in the question, guys. So here is F1 multiplied by, look at the formulas we did. Look at the formulas we did. F1 is F multiplied by sine. So F1 multiplied by sine, the angle is 30 degrees. 30 degrees. Let's quickly look at the question to get the values. There it is 500. So it's 500 is equal to 500 multiplied by sine of 30 degrees, and that one is equal to, let me just do my calculation. You can also do calculations. I'll give you a chance to ask questions at the end, but let's quickly do the calculation. Is 500 sine of 30 degrees. This 250 Newton. So we get 250 Newton. Now, I'm going to go back to the drawing just for a second and look here. It is to the right. This drawing is important because it's going to help me to know in what direction is the component. We need that one because we have to calculate the resultant of X and the resultant of the Y axis. So it's very important to know the direction. So let's see. I'm going to write here, right? And this one is just for me, okay? When I mean for me, it means the person that is answering the question. Okay? Take this one is with the light. There we go. So now F1 in Y, of course, if this one is sine, it means the Y will be cos. Nothing to say about that one. So this one is F1 cos of 30 degrees. And what do we get here? Which is 500, sorry. 500 cos of 30 degrees. How much we get? Let's do the calculation real fast. I don't know if you see the calculator there. It is 500 multiplied by cos of 30 degrees. And we get that is 433,12. This one is equal to 433, 0.01 Newton. Now let's go to the picture. In what direction is that? It's going to be up. It's going to be up. All right? You can see here, this one is the component of the first force. It's pointing up, and that is extremely important. So 433.01 up. Now we repeat the same. We repeat the same for the second force, or force 2. Same story. So I'm going for force 2. Force 2, remember not to memorize this because now it's different. It's a different one. Now they change according to what side is opposite and which side is adjacent. So F2 in X is equal to, look here, let's go back here. F2 is this force here down. The X component is the adjacent side, so I'm going to use cos. In this case, they change, so it's going to be F2 cos of the angle, and the angle is 50 degrees, that you can see, 50 degrees. So if you substitute, you get that is, let me write the number from here, it's 600. 600 cos of 50 degrees. There we go. And then we calculate. I don't think you need to look at the calculator. It's not very important. Let me calculate here. It's not very important. You can calculate yourself, guys. 600 cos of 50. And I get 385.67 Newton. In what direction is it? Let me move it up. There we go. In what direction is it? My picture, which I recommend you to do it. X component on the force 2 is also to the right. So we're having two forces to the right. So there we go. Here is right. There we go. Okay. And now we are going to calculate the second force, but in the Y component. All right. Let me move it a little bit up here. There we go. F2 in the Y-axis is equal to F2. If this one is cos, the Y-axis then must be sine. There we go. If you substitute, you get that it's 600 multiplied by sine of 50. And then the answer is going to be, let me calculate it here with the calculator, 600 multiplied by sine 50. This one is 459.63. Round off the final answer to 2 decimal places all the time. Okay, make sure you write or you round off to 2 decimal places. That's another mistake that learners can encounter. Okay, now this one is Newton, and if we go to the picture, you can see that the component or the vertical component of the second force is pointing down, right? So the second force, the component, let me take this one off, man, just like that, there we go. It is pointing down. I'm going to write down. There we go. And that is how we resolve all forces into components. All forces are into components. You make for me? The coffee? Okay. Right. So there we go. We're going to continue, and I'll give you, you can, if you have any question, you can ask at any time. Yeah, the final answer, you always round out the final answer to decimal place. I'm going to finish, and then I'll give chance to all the questions. Let's do that this time. Do the calculation with me, and I'm going to, because it's difficult, I have to be changing cameras here to read the comments, okay? So I'll give a chance for all questions. But yes, I see somebody's asking about always round off and right direction. The direction in this case is for me. You will see why it's for me, because the question asked me now to calculate the Rx and the Ry. So direction is extremely important. Rounding off, very important, because the final answer, if it's not rounded off, you lose marks. All right, the final answer, not the middle steps. This one is the final answer for that specific question. If we look here, that question says resolve each into component. It is the final answer. It's the calculation of the component. That's it. All right. But if it's a middle step, like you're doing a calculation to substitute later on, do not round off that middle calculation. You round off only the final calculation. All right. So guys, this one is the component. Now, we still have to speak about F3. And we spoke about F3 already a little bit. Now, in F3, what happened? What happened to F3? The force is right on the axis. It is on the x-axis. It means this one is actually F3 in x, or is F3, because it's right on the axis. But this force 3 does not have a vertical component. So F3 in y is equal to 0 Newton. You do not even have to write it. It is 0 Newton, end of the story. All right, but the force that is on the axis, it doesn't matter, this one is on x, but it could be on the y-axis. If you have a force that is on the y-axis, that force will not have an x component. Okay, I hope that is clear. And that is the first question. The first question is finished and clear. The first question is finished and clear. Then the next question say, calculate the net force in x, and the next one say, calculate the net force in y. We can treat the two questions together to save some time. Let me move this one slightly up. There we go. So calculate the resultants in x and in y. And that is why I did write direction. That is why I did write direction. Because we are going to work only now with the x component. Let me move this one a little bit there because it's enough space here. It's enough space for us to calculate all this one. Let's see if I can use this color. I hope I can. Whiteboard marker. Okay. So now let's go for let me move it here. There. Let's go for F. FR in X. Now, this, I don't like this one. I'm sorry. I don't like that one. I don't have the blue one. F R in X. There we go. Now, FR in X. To do this one, we have forces that are pointing to the right and forces that are pointing to the left. Let's go back here. Look here. We have two components that are pointing to the right, and this one is important for Newton's law because you will have to apply Newton's second law in X or Newton's second law in the y-axis. So this is where the Newton's second law come and take an important part. All right, we have one force pointing to the left, and we have two forces which are the components of F1 and F2 pointing to the right. So they are pointing in different directions. It means you have to select a positive direction. Now, when you go to Newton's law later on, it is recommended to use the direction of motion as positive. Here, let's say we don't know in what direction it's moving, but let's take right as positive. So here, I'm going to write this one, and I'm going to write somewhere, and it's important for this specific question, right positive. You write it so you can see it. Don't stress much. You can write it. You will have the space to write it down. And now I'm coming here. That is why I wrote the direction. We have one force here to the right, which is going to be positive. We have another force here to the right, which is going to be positive. And the last force is this one, which is pointing to the left and is therefore going to be negative. Saying that, how we calculate the resultant in the x direction. Let me say it's difficult getting full, and I don't want to actually clean everything. So we have 250. If you've been following me, you can see 250 positive plus 385.67 minus, because it's pointing to the left, the 450. And that is going to be giving you the answer. Let me calculate quickly. 250 to 50 plus 385.67 minus 450. Yay, 450, and that gives me 185. If my calculations are correct, and 85.67 to the right. Also important that that one is to the right. So it's going to be 185.67 0.67 Newton. Right. It is important to write that is, or identify that is to the right. I'll show you what. For the next question, is very important to know. All right. So this one will give us the resultant on the x-axis. This one is the resultant on the x-axis. Your teacher at school maybe tell you the horizontal resultant is fine. It's not a problem. It could be either one. And then we have to calculate the resultant in the y-axis. Now, in the y-axis, if we go back here, I'm going to answer some here at the bottom. In the y-axis, you can see that we have a force pointing up and a force pointing down here, the components. So it's the same story. We have to decide which side is positive and negative, and it's not that important. You can write it as you want. Whatever direction you select is fine. Let's take up as positive just for this question, but remember, in the direction, it doesn't matter. You'll get the same question. So I'm going to write here, up is positive, and then we have only two forces on the y-axis. The component of the first force pointing up, the component of the second force pointing down. If we go here to the substitution, we have that this one is up for 433, it's up, and then we have here 459.63 pointing down. So that is what I'm going to substitute in here. Let me see if I substitute, and I have to do it here, and I'll show you now, because otherwise I won't be able to see. We have that is 433.01 positive minus the other component, which is 459. Let me write it here. 459.63 is negative because I set up is positive. It's negative because I set up is positive. Otherwise, it won't be negative. And then the rest is to calculate that simple calculation with your calculator. Let me use it. Let me use it for 33.01 minus 459.63. If my calculations are all correct, that you are more than welcome to please calculate the same numbers with me. All right, and see, correct me if I'm wrong. I got negative 26.62 Newton. Now, important, that negative is not a negative number as we do in mathematics. This negative number has a meaning, which is direction. I said at the starting of that question, up is positive. If you get a negative answer, it means that is down. I am going to write the same number without the minus, and I'm going to write 26.62 Newton, but I'm going to write in word down. And then we are done with that specific question. Common mistakes here learners make, they do not select the direction, and they either add everything, they do the addition, they plus all numbers, and of course they're going to get a wrong answer there. Let me just go here in case that this. Yes, it will stay. It will stay in the channel. It will stay in the channel even when I finish the live. It will stay. The only thing is live, you can ask questions, which is the fun part of the live. You can ask questions like you have now a tutor. You can ask questions and I will answer. But if it's you watching later, then the questions is offline, so I'll have to answer eventually. I will answer eventually. Okay, so that is the question. We have done most of the question. I said it's a small stream today. It's a small stream. We did question 1, 2, and 3. We have to determine the magnitude, the resultant, and the direction. All right. For this one, I'm going to clean what I don't need anymore in my little whiteboard because there is a lot of information that I don't need at the moment. All right. There we go. There we go. Let me raise up this one. I'm going to leave. I need some information, which I'm going to leave, but there's some information I don't need right now, which I'm going to clean because I need to use for the question. There we go. For now, what do we have? What do we have? You see nothing there, but you will see. We have one force that is to the right, that is the right component, the resultant on the x-axis, and we have one force pointing down, which is, you know what, I can do this actually for you to see it. There we go. That is what we actually have, okay? We have a force pointing down and a force pointing to the right. I highly suggest to do a rough drawing because the rough drawing will help you to determine the direction mostly. We have roughly, and I'm going to write it here, we have a force in the x-axis, which is this one, that is F R in x, which we did calculate. I'm not doing nothing else. This one is equal, or it was 20, no, it is here, 185.67 Newton. I am not going to write direction because in the drawing you can see the direction. All right, now where is the y? It is pointing down. So from here, I'm going to draw the head to tail or tail to head, just in case somebody needed it. If you draw it from here, you draw it down. This one will give you F R in Y. And F R in Y will be equal to 26.62 Newton down. I am not going to write down because you can see it in the drawing. Where is the resultant going to be, which is actually what we are looking for? The resultant is going to be from the tail of the first vector to the head of the second vector. This is the resultant. It's supposed to be straight line. The drawing was terrible, very bad. Let me see if I can. You must do this one with a ruler, guys. Use a ruler. You have a ruler. For me, it's difficult to do the life with a ruler. That one is FR, which is what we are looking for. All right. Which is what we are looking for. How we calculate that one? Well, that is the hypotenuse. So all we have to do is to use Pythagoras to calculate the resultant, the magnitude of the resultant. With Pythagoras, you only get the magnitude of the resultant. But before we calculate, let's go to a common mistake. A common mistake which I did in my channel in one of the shorts I done it, but it happens often. And is if you instead use the tail-to-tail method. Now, if you use the tail-to-tail method, it's fine. You have here FR in X. I'm not going to write the numbers because they are here. This one is FR in X. And then if you use tail-to-tail, here is where you draw the FR in Y. Now, where the mistakes come with learners, learners join these two heads. And this is wrong. Is wrong. You cannot join those 2 points. That is completely wrong. And it's happening to, I'm speaking about top learners that are too in a hurry to stress, I don't know, and they join the line because it's easy. It's the magnitude will be the same, but technically speaking, it's wrong. It's not the right way. Even if you calculate, you will get the same magnitude, right? But it's wrong. You won't get marked because it's wrong. The correct way is now to draw lines that are parallel to each of them. So you draw a parallel line here, like this, and a parallel line here, like this. There we go. We have parallel line to each of the vectors. And then the resultant will be from where the vectors start to the point where those parallel lines cut. This one will be the resultant. And if you look now, you compare, we have the same one. All right. Now, this was not part of the question. This is the rough drawing because I want to know the direction. Eventually, you have to calculate the direction, and this one will help you to identify what direction you are going to use. In our case, we are going to calculate this angle when the time comes. We're going to calculate that angle. Okay? So that is the, in terms of drawing, and it's a, how can I say, it is a rough drawing. This greeting, hello to you all. Much love. We continue. Now we're going to calculate. Now we're going to calculate the magnitude real fast, and then the direction. This one is real fast. Magnitude, Pythagoras. Magnitude of this resultant is Pythagoras. How do you use Pythagoras? Let's write it here. FR square is equal to FR in X square plus F. I'm going to use FR, but you can use just right. You can use just R. FR in Y square. This one is the theorem of Pythagoras. Common mistakes, learners forget the square of the FR. If you do that, you get 0. Note the following. In physics, if you make a mistake with the formula, with the starting point, which is a formula, if you make a mistake, you get 0 for the whole question. Nothing to say, even if the answer is correct. No marks. Okay, so from here, we're going to substitute. Let's substitute. All right, FR square is equal to FR in X squared. We have it here. It's 185,67 square plus, and then the last one is the Y component. It is 26,62 square. Note the following, and many learners ask me, sir, it was negative. Yes, but this is to the square. So you don't have to substitute the negative. Everything is positive in this formula, because in this formula, you are actually calculating the magnitude. So the minus doesn't matter in this formula. So don't bother about substituting, or do not substitute the minus. You will get the same answer. Okay, not here. This must be positive. And then this is just calculation FR square. I'm going to do it step by step quickly, just for control, to show you. This one is 185,67 square plus 26,62 square, and we get that is 3,000. Note, not the final answer. I'm still doing step. Né? This one gave me 3,5181,97. But now this is the square, so we have to actually get the square root of that answer, and then the square root cancel here. This is mathematics now. The physics is done. The physics is done here. All right. So now FR is going to be equal to, if I go to square root here, I got that is 187,57. Guys, please recheck the calculation. I always tell my learners, calculation is not as important as the way of doing it. I have a little bit of dyslexia, so maybe I mess numbers up and down. You can do it, and it's not a problem, okay? You can do it. You can compare your answer with mine, and it's not a problem. So this one is the magnitude of the net force, not the direction. For the direction, which I say we're going to calculate that angle there, we're going to use tan of theta. So if we use tan of theta, and this one is also mathematics, not physics, not too much physics involved anymore. Tan theta, let me just check here before I even go on. 29, okay, I make a mistake here with the FY. Okay, so Omolemo says that I make a mistake with the F in Y. It's fine. Guys, fix it, please. You fix it. I'm going to leave it. I'm not going to write now the whole thing. I love that input. Fix it. Make sure it is fixed. And you continue, okay? You continue. So we're moving on. We're moving on. You know, the numbers, you fix the numbers. I do not bother about numbers as much as the method to do it. All right. So let's move on to get the direction, because I want to finish. I don't want to have a very, very long. Let's go here. Let me fix this one. Now the direction. The direction, we're going to calculate theta. Now for theta, what? Where's my color? Let me use this color here. For theta, for the direction, it's nice to see faces I know on the stream. It's very, 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 very nice. Okay, now tan of theta. This one is what matters, the method to do the work. Okay, it's always opposite side over adjacent side. We start the stream writing this one. Which one is the opposite to the angle? If we go here, opposite to the angle is FR in Y, and opposite to the, and adjacent to the angle is FR in X. All right, so we move in here, and we have that is going to be F in Y. I wrote 26,62. It might be a mistake with the calculation. Omolemo on the stream says that. Please fix it if it's the case. I'm not going to do it now, because that it means I have to erase everything and start calculating. Okay, and then the adjacent side is going to be 185,67. If you calculate that one, let me just do it quickly here. This one is 26.62 divided by 185.67. I got 0.14. This one is not the angle. 0.14. This one is not the angle. This one is 10 of the angle. So to get the angle, I'm going to write it here. Theta is equal to 10 of the minus 1 of the answer you got. Not the equal, the answer. 10 of the minus 1 of 0.14. So when you do that, let me just do it in my calculator of 0.14. I got the angle to be 7.97 degree. That is the angle I got. Now, that angle, if you look, is to the negative side of the x-axis. It's like moving clockwise from the positive x. This one, now we're speaking about maths. This one is the positive x-axis when you're speaking about axis. Now, there are different ways of giving a direction. You can say clockwise 7.97 degree, clockwise, from the positive x-axis. Or if you use in terms of the axis, you can say to the negative x-axis. Negative means moving clockwise from the positive x-axis. Guys, this is the end of the question. And we did the whole question. I hope you understand. I hope it helps. If you are one of my learners, you know you are going to write the test next week. Small test, and there will be a question that is similar to this one. Okay, important. I'm going to repeat this one. Important, more important than actually the numbers, the value, the answer is the method. The answer, the final answer will only have 1 mark. So if you get wrong that one, I mean, you lose 1 mark. It's not right. You try to not do it wrong, but you lose 1 mark. But if you lose the method, you use all the marks. Right. So that is the question. Now I just want to see if there is any question. Any question regarding this specific question, this specific exercise? We've been now for 40 minutes. It's fine. So I'm going to wait a few minutes for questions that you have. If you have any. If you have no question, then we'll stop the stream. Omolemos, thank you. You say that it's 29.62 actually. FR. Yeah, maybe I did see it and then I got wrong, which is normal with me. Let me just check it. 433 is, oh my calculator. 433.01 minus 459.63, and that gets, okay, I got 26.62. I'm still getting 26.62, but guys, check. You can check all the calculations, okay? So yeah, I don't know. You can ask questions now if you have any. Let me just fix this one. There we go. There we go. I hope it helped, really. I hope it helped. I know there's a lot of mistakes learners make with this question. Next Saturday, we do another stream. I'm still deciding if it will be for grade 11, grade 10, or grade 12. I'm still deciding. I'll try to do one stream every weekend, every Saturday at the same time. But the topic is to be decided yet. You can always write comments and so on. Okay, so there is no question, guys. I thank you all. I hope it helped to clarify. Thank you very much. I hope it helped. Guys, you can always ask questions and I will answer. I mean, even if it's off stream, it's fine, I will answer. Thanks a lot, guys. Much love to you all. I don't see any question regarding this question, but you can write a comment. The stream will still be there. You can write the comment, and guys, we'll be there again next weekend. Newton's law is coming, and it's extremely important for grade 12 and 11. Most of the marks in grade 11, most of the marks in grade 11 term 1 will be for Newton's law. Most of the marks in grade 11 at the end of the year will be Newton's law, and a vector will have a lot of marks. Okay, so I'm right now in Kimberley. And some of the learners using the stream are my own learners. I teach in a high school, and yes, but I'm actually from Cuba, so you might hear a little bit of accent, very small. I'm actually from Cuba, so my main language, my first language is Spanish. Newton's law, the topic requires a lot of time because it's not like vectors. Newton's law is a lot. It's a lot, and it's very important. And then it's going to be in grade 12. So I don't know how long it will take, but we'll make it very easy for you guys. We'll do a lot of videos, and we'll do a live like every weekend. But well, if there is no question, guys, much love to you all. And then I don't know, the rest of the weekend, enjoy it, and have a good day. Bye-bye. Much love to you all.